Hello, my name is Stephen Burns. I'm a geophysicist, and today I'm going to show you how you can take Geometrix land magnetometer data and process it all the way to a finished product like we see here. This is from a survey I collected over a small goalie, and it was with a single sensor mounted on a staff using the G864 magnetometer. It was sampling at 10 Hertz, and I collected my location data using GPS. We'll be applying a diurnal correction to this data to remove the Earth's magnetic field, and we'll be using a few different programs. First, we'll be using Geometrix Survey Manager software. We'll also be using MagMap, which is another Geometrix program, and Geosoft Oasis Montaj Field to process the data. So to start, we'll open up the survey, and this is taken off of the tablet. This Geometrix uses a tablet interface for their latest land magnetometers like the G864. So you simply just export that DBT file onto your computer, and we would just hit open on that. And this is very simple. Survey Manager software has quite a few features, but here we're simply just exporting a CSV, and we'll do it with locations. Hit export, and we'll call this goalie because that's where we collected it. Make sure you save your files with names that make sense, and if you have a complex data set or many data sets, you have to be very precise with this. But for the purpose of this example in this video, we can keep it simple. So we'll save it as a CSV, hit save. It will save, and then let's now go and download our base station data. I did not have a base station magnetometer available when I completed this survey, so we can rely on InterMagnet.org and their network of publicly available base stations. And we see here there's a whole bunch of different ones. I was in Utah, so here we have the Boulder, Colorado base station, which is the closest one. I would use that. Notice the IAGA code here for Boulder, BOU. And we can go to the data download tab right there, and we can type in what we want. So we'll choose a second, best available, data format, that's fine. And this was on the 18th of August, 2021. So we'll click that. We'll search for our data, and it's going to load all the different base stations that they have, but luckily Boulder here is right at the top. We click plus, add file, scroll down, download. There's a conditions of use. We'll type in the email, I accept, and download. Just save this to your directory. It's a zip file, so you'll need to extract that. We'll do that next. There we go. And we can load this up and now extract the file. I like to delete the zip file to save space. And there it is right there. There's conditions of use, a log, that's the one we want. So now we'll use MagMap, which is a Geometrix program, to apply the diurnal correction. And there's a few nuances here which are important, so I'll guide you through it. We'll go to File, and we'll go to Open, and we'll click on our base station data. The first nuance is it's very important to choose the right file here. If you don't choose the right file type, it will not import correctly. Nor can you just simply go all files and then click this. That will fail. So here we want surfer.dat, interpolator.int, int, text, comma separated, the whole deal. So we'll click that. We'll click our file. We'll hit open. And now we want to, there's no position information here. We want to assign our timestamps. So there's our time in channel 2. Here's our date there in channel 1. Make sure it's on the right format. So year, month, day. It even says InterMagnet right there. And we want to add our data channel. So I've already added it, but to show you what this looks like, I will open up this file with Notepad, and you'll see here in Notepad that it has a date, a time, a X component of the magnetic field, a Y component of the magnetic field, Z, and then the total field measurement. So it's that total field measurement that we're interested in. So if I go back to MagMap, you see that was column 7, and I could choose from the different columns. I already have it there, so I can simply hit cancel this time, but you want to add that. And then you want to load this as a base station. So you hit OK. It loads in, and there is our wonderful magnetic field of the Earth as measured in Boulder, Colorado for the day. So interesting pattern there. Now we can go and open up our data that was collected over this goalie. And again, for this CSV, we want to make sure we have this one chosen. There's also CSV here. That one will not work. So make sure you choose that one and hit open. And there's a few steps here. So first, we want to load in our X and Y, which is our longitude right here and our latitude here. This was a GPS survey. And we want to check here if X and Y represent longitude and latitude. If you don't do this, you won't be able to export the data. Then again, we want to assign our timestamps and our dates. So there's our time there. The first one's counter and then date. So then there's time, and this one is our date. Again, it's in the same format as the InterMagnet. So year, month, day, looking good. We want to make sure this is clicked on. Don't use lines, all data in one line, and we want to add our data channel. And here, we already have our longitude and latitude added. We already have our time and our date. So all we have to do is choose our magnetic sensor. Again, it was a single sensor survey, and that is here. So we click that value, hit OK. Positions and data, that's how we want to load it. And you'll see there's the other options, base station, positions only, data only. We want both. Hit OK. So we'll notice that there's some dropouts here in the data. We'll correct that using, like within Oasis Montaj Field. It's easier to do that. You could try to do it here in MagMap, but I think it's better to do it in Oasis Montaj Field. Here's our GPS path for the area. And you'll want to be on this window to export the data. So you can go to window here and cascade them if you want. And we'll see we have our diurnal data. We have our actual survey data, which right now you can't see the nuance of because of the dropouts. But if we go to our location data, we can right click and hit export. So the format that we want here is text, space delimited. You can also do Geosoft. You can do some of these other ones. They all work, but I'm just going to do a text space delimited file, and you can sometimes hit browse and type in the name, but I'll simply just, oh, there we go. And so I will actually browse and go to there, and we'll call this goalie diurnal correct data. Okay, hit save. And now hit export. So there, it's been exported. We can exit MagMap, and we can now open up Oasis Montaj Field. This is a lighter version of Oasis Montaj. So, and they're very similar. So you can use this guide if you're Oasis Montaj, if you have the full license. We'll start by creating a project, and we'll do this in our example landmag directory, and we'll call it goalie. And it's a GPF file. Hit save, whatever you want to name that. And there's a few steps to this. We'll work through all of them. The first is import a database, which is going to be our data. So we'll go to database, and we'll go to import. We'll go to ASCII2. And we'll choose our file we want to import, which is our goalie diurnal correct data. Click OK. And we'll call this goalie dol data. Dol for diurnal. And we'll hit OK. it's going to give us another option box here. So here it's showing our different columns. We have our longitude, our latitude, our mag values, and then our actual diurnal correct values, time and date. So we can go next. We can see that it's separated them out there. Thank you very much. We hit next. And our data is ready to import. All the columns have been assigned. You can see here that if you go to date, for example, the format, actually you can change the format to line up with what it is. So it's month, date, and then year. So we'll do month, date, and year. And then for our time, it's hour, minute, second, and second. So we have that as well. So we're good to go. We can hit finish. And there is our database. And as you see, it's quite large. You don't really have to scroll through this all that often. We will be doing a little bit of investigation work because of those dropouts. So we'll do that now. You can right click on, and you can just actually plot your mag sensor if you want to, but we're going to plot the diurnal correct data. You could plot, for example, both to see how they compare. So we're going to right click on that diurnal correct area, and actually you'll notice here that it shows negative values. So you can see how it's taken out the Earth's magnetic field readings there. So we can just again click there and hit show profile. And here we have our profile at the bottom, and again these big dropouts. So we can right click on this area, maybe even increase this box to make it easy. Right click and hit zoom. And when you hit zoom, you left click. Sorry, let me do that again. When you zoom, you left click and hold to create your box around that area. Then you hit left click again to go into that zoom box, and I can simply just left click there to find the weird values. And if we look up here, we see we have 4 values which are out of line. So if we go over here and click those, we can highlight them and then delete them. So we'll hit yes. It's deleting them now, and I can then right click and hit rescale all. Now that's nice and flat. We'll go to zoom again left click and drag, click, and here we see that we have 2 values out of place. So we can delete them. And you just repeat this process. If you don't have any dropouts, congratulations. If you do, then just go through the process and it's not too hard. We'll rescale, zoom. And you'll also want to check it after you delete the last dropout because it will dynamically rescale and you might find some new dropouts that just weren't as large as the first. So we have a few dropouts here coming up that we'll deal with. And it's really careful. You want to make sure that these values, your first or final dropout might be 100 nanotesla off or 300 nanotesla off. It might not be as obvious as this, which is like 10,000. So be very prodigious in measuring the difference between your dropouts and not. And the way I know these are dropouts is because I'm sampling at 10 times a second. So for something to drop out, for something to go that far down or up and change in 4 readings in 4/10 of a second is not really possible. So that's your sign that it's a dropout. So we'll rescale. We have maybe our final section. I think this guy's probably a little dropout too. So here is a smaller one. You can see it's separated by about 600 there. We'll just delete that. Processing this data doesn't take too long once you know your operations and you just kind of cruise through them. Here's another one. It shows the 916 you see. And we'll click that, go there. And we actually have our next one right in sight. So go there. And I bet we can find the next one just by scrolling. We can. And same deal here. That one is -5, where the others are -267. So that's a close one. You want to make sure you delete it. And one more. So we'll delete these. Oh, it looks like there's still one hidden. Okay. Delete those. Actually, delete these 3. That -372 is out of place. And now let's rescale. And this looks a lot better. So we'll go with this data set here. This is a little sharp right there. Maybe we zoom in on that and check it out. But if we see here, it's a, what, 30, it's a 50 nanotesla drop, but then it has this nice increase afterwards. So whatever that is, we're going to leave that. We have some other drops here. There are anomalies in the field, so you can't just smooth everything to oblivion. Your data won't actually show what's there. So we have a good data set here now. We see the profile. Those timestamps simply have been removed. They've all been less than a second long, so it doesn't affect the final data in any noticeable way. It just improves it. So the next step is to, and you can just simply drag that down again if you want. Next step is to assign our coordinates, and this is a kind of complicated step, so pay attention here. So to start, we'll set our x and our y, and our current x is going to be longitude, which is right there. You can see that going there, and then our current y is latitude. So we'll hit y, and we'll skip elevation. We'll hit OK. And now we see a little X and a little Y blue marker on those channels. So that's good. And you can plot this data in lat long, or you can plot it in UTM. So you can do a conversion. So we'll show both. First, we'll show the lat long. So it's actually ready to plot already in lat long. So you just go to grid and image here. Gridding, simplest method is minimum curvature. Click that. We're going to click the DOL channel right there. So we can click that as our channel to grid. And our output grid will be goalie DUL lat long. And for lat long, you'll want to choose a, this is kind of difficult to figure out, but I was walking about 3 meters in between lines, and the grid cell size to use for something like that would be 0.00002. Because again, your grid cell size is going to be in lat long, which is quite large. So you can't put like 2 for meters. It has to be a very small value. But we hit OK, and we'll see our data pop up momentarily. Here it is. Doesn't that look beautiful? So that is our diurnally corrected data plotted in lat long, but I'm going to show you how to convert it to UTM as well. And we'll just expand that grid there. We'll go back to our database and we'll go to coordinates now. We'll set our coordinate system. So we hit yes. Already chose X and Y channels. And you'll need to set your coordinate system before you can set your projected coordinate system. So didn't necessarily need to do it before, but need to do it this time. And it's taking a little longer than normal. That's fine. So our coordinate system is just at the bottom of the global here. It's lat long, right? So you go there, you go to world, and then you simply click WGS 84. So pretty easy. Hit OK. That's all done. It's just loading. Okay. Now we can do new projected coordinate system. So again, we have our X, our Y. You'd hit next. This one is just confirming effectively the first step that I did. You might even be able to do that step in here. So we see that our current coordinate system is WGS 84. That's great. You hit OK. Now you create a new X and a new Y channel for the projection. So we'll call this X underscore UTM, and we'll call this Y underscore UTM. There we go. Hit next. And now you'll see the current coordinate system here. What you'll want to do, you don't want to mess with this at all. What you'll want to do is you want to hit modify, and then go to coordinate system projected. Once you're there, you can go to the projection method, see the little star, and you can find how you want to project it. In Utah, it's UTM 11 North or 11N. So we'll simply find that. It's right up here. So it's UTM 12N. So we have UTM 12N right there. Very good. And you hit OK. And you hit OK. So you've now created, it'll load in just a moment, you've now created a UTM XY channel, which is right here. And maybe, well, let's grid it and see. I'm not sure why it's showing the little asterisk there, but we'll set our X and our Y, should work, and hit OK, and then we can go to grid and image and do minimum curvature. Same thing, we'll grid the same channel, and we'll call this UTM because we're creating a different grid file now. I'm actually going to hit cancel because I deleted a period there. I just like to be very careful anytime I do this. So UTM. And we're going to want to change our grid cell size, so we'll change it to 2. So this will give us a 2-meter reach on each side of the location for what I walked. And since I was generally walking with a 3-meter swath, this will fill in everything nicely. Hit OK. And it's going to load up our grid. There it is. We can see that they basically look the same. So now we'll go, I'll show you how to draw the base map and everything. So we're near the end. You simply click Map, Tools. Well, actually, yeah, sorry. First you click Map and we create a new map. And it pops up with the data range for the map. So we need to figure out our data range. And to do that, we would click Scan Data. And it'll simply just scan the data and pull in the relevant values. So we have them here. Our mins, our maxes for the UTM, and our distance unit is meter. And you can see here it's WGS 84, UTM zone 12N. So we have the split coordinate system. Hit next. We can create our map name. We'll call this goalie. And yeah, just goalie. And the map scale will be fine. Distance unit is meter. We'll hit finish. This will pop up a blank map canvas, you could call it. Just simply expand that, expand your maps there, and just drag your UTM into your map area. And there you go. There it is. If you have this hand grab icon, you won't be able to click anything up here. FYI, you'll have to click again. Maybe it'll fix that. And now you can draw a base map. So you go to Map Tools, Draw Base Map. Here are your different options. Make sure you get your margins nice. I'm probably going to make this 2 and keep that 1. So that will be good. Hit next. And it preloads everything. You can change your line colors and all stuff, but I like how it looks by default. We'll give it a title, so we'll call goalie. Let's keep it simple, but for our subtitle, we'll call it a total field magnetic data diurnally corrected. We'll call this goalie map. And our subtitle will be single sensor 10 Hertz GPS survey. Hit finish. And that map will draw. Look at that. How nice does that look? And to put in our legend bar, we go to grid and image, display on map, color legend bar. So we click that. And the way I like to do this is just to simply figure out my bar orientation and then just click where I want it to go. So you'll see here I have lots of room on the side, not much going horizontally, so I'll click vertical and I'll hit locate. Now, when you do this, it draws it going up, so you're actually locating the bottom of your legend. So make sure you don't click in the middle, it'll shoot off the top. So click it nice and low, and click somewhere in the center of that side area of your map. And just like that, you've now put your X and your Y in, hit OK. There it is, our color legend bar, and it's looking very, very nice. You could also load in your GPS track lines if you want, though for the purpose of creating a nice map, that's not typically needed. I will show that after I export this map first, so it doesn't get too cluttered. So for exporting the map, you would go to Map, and then you hit Export. Whole bunch of different options. We're going to export it just as a JPEG. And to do that, you go to JPEG high quality, and we'll type in just 2000 pixels there for width. And there's viewed region or full map. We want to export the full map. Hit OK. And you can see we already have goalie total field magnetic map there. I'll actually just resave over that. Well, I guess that didn't work. Let's do that again. And it's ready. Change that again to 2000, but it's still on full map, and that's great. I'll just give it a name called Final. Hit save, and it's creating our new map. If we go here, you can see a whole bunch of stuff's been added to this directory. That's what happens when you use Oasis Montaj. It needs to do that, but if we click our final map there, here we are. We've now arrived at our final map from start to finish. I'll show you how to add those GPS locations as well. So we go back to Oasis Montaj. You can exit out of MagMap too. And we will go to Map Tools and Symbols, Location Plot. So you go there, and your mask channel, you don't have to worry about that. What is important is your size. So we want to make sure that's small and not too obtrusive. So we'll choose 0.5 millimeters. Even that might be too big. We'll see. And you can have your weight. We have light. Let's do ultra light. And we'll hit OK. And it'll now draw our GPS location. You can see I was wandering around everywhere because this was a very rocky and scraggly hillside, so it was difficult to get nice perfect lines, but I did fill in the whole area of the survey. So that's how you add your GPS location. This is how you process data from a Geometrics land magnetometer all the way from start to finish, from that beginning, where is it here? From that beginning GDB file, I think it is. Heck, I can't even find it now. There it is. The DBT file. So the 10 Hz 1 mag staff DBT file. We took it through Survey Manager. We took it through MagMap, Oasis Montaj Field. We used the base station from InterMagnet, and we arrived at this beautiful map here that we see. Nice, presentable, and there's much more that you can do. But for the purpose of a beginning explainer video on how to do this, how you can take this data and process it all the way through very simply, and it's still a very good data set that is you can start to interpret. That's how you do it. So thank you so much for watching this video. I hope it was helpful. If you have any questions, please leave them in the comments below. And if you liked the video, if you found the video helpful, please click that like button. It helps to show this video to other people who have similar questions in terms of data processing and how they can do this. So I hope this video guide reaches as many other geophysicists as possible. So you can like the video, or if you know people that need to learn this, you can also share it with them. So thank you so much again for watching. Have a wonderful day, and blessings to you all. Namaste.